Uh, Today's lecture is the second lecture. It is dedicated to introduction to geology. Last week's lecture, it was, we can call it introduction to geotechnical engineering. We all know that we are studying geology not because we need to be geologists. We are studying geology because we need to be engineers. So we are not studying all aspects of geology, nor all introductions to geology. We are studying the part of geology that is related to our study. This is number one, for continuation of our engineering study. And we are studying the part of geology that is related to general knowledge that any engineer should know. So from geology, we are taking two parts. The first part, as I said, the general knowledge that any engineer should know about geology, even if we are not going to use it in our work. The second part is the part that will help us in our work. And as I said in last time, that to study any subject, I need to know why I'm studying this subject. What will happen if I do not study this subject? Some subjects are very clear. If I'm a medical doctor, if I don't study, people will be sick or people may die. This is very straightforward. But in our engineering world, we need to see ourselves what would happen. So in last lecture, you will see it later, what may happen if we do not study geotechnical engineering, which is related to geology. This was last lecture. We will not go through it now, but we will concentrate on our lecture of today, which is introduction to geology itself. I will only use one slide from the previous lecture because it is important in our introduction to geology, which is what is the difference between geology and geotechnical engineering, and what is the difference between, we say geology. Geology is the science of geo. Ology means science, so it is the science of earth. Geo in Latin means earth. So what is the difference between the science of geology and the engineering of geotechnical? Why don't we call it geotechnical science? Similar to what we say, geology is a science. So let's start from the beginning. We have here the science. The science is divided into applied, natural, and social. We are going to study the natural part of science. The natural part is divided into biological and physical. We'll take the physical part. The physical part is divided into physics, chemistry, earth science, and astronomy. We'll take the earth science because if we are studying the earth as engineers, we deal with the earth, so we need the earth science. So we'll study the earth science. The earth science, these are the divisions. This deals with the weather and everything around us related to weather. We also have geology and hydrology. These are the two sciences that are very important for us as engineers, especially if we are geotechnical engineers. So geology and hydrology, both sciences are very important as they are the base of geotechnical engineering. So now we know the relation between geology and geotechnical engineering. The next step is, why do we call it engineering, not we call it science? Why geotechnical science? Simply because we need to know what's the difference between science and engineering. Science is the study of the world around us. Scientists study all the features of the world, everything around us, they study it. But they are limited to the study. They may have questions. Today, there was an earthquake. Some of you might have felt it or not, but there was an earthquake. Scientists will say that today there was an earthquake, the magnitude of the earthquake was so and so, and its location is so and so, and they will give you complete data about the earthquake. But they cannot tell you what to do to keep your building safe. So the end of the task of the scientist is to tell you, you have a problem. What can I do? I will bring an engineer and tell him, I have a problem, please solve this problem. I need my building to be safe till an earthquake of magnitude 7. So he will design. By the way, 7 is very high, but if you are at the epicenter, you will feel it different than if it is at another, if you are away from the center of the earthquake. So, but anyway, we'll ask the engineer, design a building to withstand an earthquake with so and so magnitude. So this is the task of the engineer, to present solution. So that's why we call it geotechnical engineering. Geotechnical engineering is the solutions provided by the engineers to solve the problems that was defined by the scientists. What are they going to do? They are going to analyze the problem, design whatever they need to solve this problem, and will construct structures or buildings or whatever that matches the design based on the analysis. So this is the relation between geology and geotechnical engineering. So now we know why we are studying geology, because geology is the part of science dealing with the soil. Hydrology is the part of science dealing with water. All the water around us is related to hydrology. If you look at our soil, you will find that the soil, if you dig a hole, you will find that it contains soil and it may contain water. So both are very important to us as geotechnical engineers. This is the start of our lecture of today. What is geology? Geology is the science of Earth. So it is a science and it deals with Earth, dealing with its composition, structure, and geological history, as well as studying the origin, properties, and composition of both rocks and minerals. So as a geology, as a science, it seems that geology is just description of what is the Earth, what's the history of the Earth, how it was created, what modifications happened to it since it was created till nowadays. Geology also studies the Earth's history since birth, 4.5 billion years ago. This is very important for us to understand that geologists, when they speak about time, they speak about billions of years. For us as a geotechnical engineer, we don't, it's not very important to us what's the history of Earth what happened, but we care a lot about what is the current condition, what is expected to happen in the future. So we only use the history to anticipate what may happen in the future, like in earthquakes. You know that this area, there was earthquake that happened millions of years ago. Is it expected to happen again? Is this area active for earthquakes? Will it happen again? Is it expected to happen again? If it is expected, then we have to design buildings to match this. If it is not expected and now it is not, it is inactive, then we don't need to design something like this. So the first thing I like to concentrate on is that geologists or geology concentrate on years, billions of years. For us, we only take the results of what they say and studies the process that shape the Earth's surface, oceans, and the interior of the Earth. So we just take from them what will help us in our study. Why do engineers study geology? To study valuable resources such as soils, water, metals, industrial minerals, and energy. All of these are found inside the earth. So we need it as an engineer to know this. To study rocks and the fossils you know what is fossils? Yes. And the fossils they contain, to understand the evolution of our environment and the life within it. This is a little bit related to geology, but it helps us to understand. Like, if I see fossils at one place and the same fossils at another place, then for me, it may mean that this area and this area were once one place, but they were separated with time, something like this. So it helps in our study. To learn to minimize our risks of earthquakes, volcanoes, slope failures, and damaging storms. This is related to geology, but it helps us to learn how and why Earth's climate has changed in the past, and use the knowledge to understand both natural and human-caused climate changes. Someone would say, what's the relation between climate and engineering? If it is hot, if it is cold, will this affect our buildings? Yes. Wind affect our buildings. We design buildings based on wind pressure. And if this wind is storm, then we have to design the buildings to carry this huge amount of, or exceeding amount of wind. Temperature, if I have hot, then cold, then hot, then cold, the change of temperature affect the materials that I use in my building. So climate and climate change is important for us as engineers. Quickly, something from the previous lecture that reminds us why we study geology. This photo may give us a summary. Why we study geology? To avoid this. You see this photo, we spoke about it last time. It's a collapse that happened within the rock surface of our Earth. This also may summarize why we study geotechnical engineering. It's a problem that happened in one of the projects. It is related to geology and it is related to the design of the engineer, so it is related to geotechnical engineering. So now we can go to study what are the branches of geology. there are basic branches, there are applied branches. The basic branches: physical geology, geomorphology, structural geology, geochemistry, stratigraphy, lots of branches. Of course, you need to know about them, but you don't need to summarize them. I'm not going to ask you to summarize what are the basic branches of geology, but there are some basic branches of geology that are very important to us. So this you have to know it by name and by definition. So these are the basic branches. These are the applied branches. It means that they are applied in field, in work, applied in our daily life. Something like well logging. Well logging means that I study I drill wells in the ground and I study the formation of soil as I go drilling. So it is something like boreholes in geotechnical engineering. So well logging is an applied study from geology. This is engineering geology, which is what we are studying. This is an applied branch of geology. So these are the important. Of course, we are studying engineering geology. But to study engineering geology, we may have to study environmental geology. Some engineers will study environmental geology. Some other engineers will study mining. Mines, you know what's drilling mines? Yes. So there are lots of reservoir geology. If we are going to you all know the crisis about the dam in Ethiopia. We know about the high dam in Egypt. It's not just any place I go and I build a dam and it will prevent water from flowing. No. The dam that I built is just a gate, but the reservoir itself is the ground. Don't think that when we say that we build the high dam, that we build a dam, something to collect the water. No, it's just the gate that closes a big reservoir. But where is this reservoir? It is made by the ground itself. So to choose the location of the dam, it should be, of course, the bottom should not be permeable. Water cannot just flow to the ground. So I have to choose a location where I have the bottom rock that do not help water to seep below, seep in very high quantities, of course. And I should have something like mountains all around to act as the walls of this reservoir. I'm not going to build a very big reservoir. I just find the place and then at the location where water leaves this place, I build a dam. So that's why reservoir geology is very important for people who are working in dams and so on. But what about our branches, main branches of geology that we should know? It's physical geology, mineralogy, petrology, structural geology, and stratigraphy. Physical geology, this is very important to us because it describes the dynamic geology, geomorphology. It deals with different physical features of the earth, such as mountains, plateaus, valleys, rivers, lakes, volcanoes, and so on. So physical geology deals with the dynamic action that led to having mountains, volcanoes, rivers, lakes, something like this. So this is important for us. I will go just directly to the structural geology. Structural geology deals with the study of different geological structure like folds, faults, joints, and conformities. Of course, these are that are formed under the influence of tectonic forces. This you will know later when we study tectonics, but it is something related to the earthquakes, that something like the earthquake we had today. What is an earthquake? An earthquake really is two plates from the ground bumping into one another. When they bumped into one another, they released very high energy. This energy needs to leave the deep surface. So it goes up and shaking everything above it. This is one thing that may lead to an earthquake. So structural geology is related to studying the different soil layers beneath us that led us to have folds, faults, anything that affects our buildings in the future. Just take it from me now, and then you will understand it when we study tectonics very, very good. So we have physical geology, structural geology, mineralogy, and petrology. Mineralogy deals with minerals. So it's the minerals. You know what are minerals? Minerals is the base of rocks. Rocks contains minerals. So minerals, the study of these minerals. Petrology deals with the study of rocks itself. So we have something, a science to study minerals and a science to study rocks. Both are very important to us, and we'll study parts of it or introductions to it this term. Last thing is the stratigraphy. It deals with Earth's history through the sedimentary rock. It's called historical geology. It is also called stratigraphy. Of course, if I'm going to put my building on the soil, do I care about the surface only, or I care about some layers beneath? Of course, I don't care like geologists. I care about 1 kilometer below the ground. No, I don't care about 1 kilometer. Geologists will tell you at this location, at 1 kilometer there is so and so, at 2 kilometers there is so and so, at 5 kilometers. But for us, we need to study, say, 50 meters, 100 meters. That's all. So to know geology, we can understand what is happening on the top surface. So stratigraphy is related to this, and this is related in our work in something called site investigation. When I go to a site, the first thing I do is to do site investigation. I try to know what is beneath the ground. So site investigation is related to stratigraphy. Development of the Earth. The Earth is a dynamic and complex system resulting from interaction between Earth's internal and external systems. The shape of Earth that we see now was not there million years ago, or 2 million years ago, or a billion years ago. It changes with time. Why this happens? Because of things that we will discuss later in next lectures. So, what are the main composition of the Earth? The Earth composed of the following: the atmosphere, which is above us, and the Earth's layer that is beneath us. Earth's layer are divided into 3 main categories. They are main categories. They are divided into sub-main categories. The main categories are, of course, this is important to know, the crust, which is the thin part on top of the soil, on top of the earth. The mantle is a thicker part that is beneath the crust, and the core, which is the inside of the earth, is very, very, very hot compared to our cool crust. Let's discuss the atmosphere. In the atmosphere, you don't need to memorize these layers just for info. You need to know that above Earth there is atmosphere. This atmosphere is divided into layers. But if this photo is just to tell you something approximate. If this is the size of the Earth, then this is our atmosphere, divided into layers. The layer that we are using, where you see aeroplanes going, is this bottom part. It's something like 14 to 18 kilometers. This is our atmosphere we see. Above this layer, there are other layers. These layers, we can say that aeroplanes may go in the next layer also. Here is just small aeroplanes, or maybe say small aeroplanes, but big aeroplanes may go in this layer. What are these layers? Troposphere, tropopause, stratosphere, ozone layer. These are layers that you should know. Of course, you heard a lot about the ozone layer. What is the ozone layer? The ozone layer is the layer that, you know what is ozone layer? It's the layer that protects our Earth from radiations coming from outer space. So this is the ozone layer that you heard of. Then we have mesosphere, ionosphere. These are all layers, but just I intended putting this photo and this other photo to see two things. You have lots of terminologies. So as I said, don't postpone studying, because we don't want you to end up a few days before the exam and you need to memorize these layers. But I tell you that these layers in these photos specifically, you don't need to memorize them, just know it as engineer. To know that ionosphere is the external layer. This is good that you know. Mesosphere is below it. Our layer that we are living in it's something like 14 kilometers compared to something like 350 kilometers for the total layers. Also, the numbers in geology are not fixed. You will see here, this is 14 kilometers, here it is 10 kilometers. This is 18 kilometers, here it is 25 kilometers. Here 50, 60, and so on. So what I mean that in geology, we don't have fixed numbers. I cannot tell you that what is the thickness of this layer and you tell me it is 20 kilometers. You will open another textbook, you'll find that this 20 is 25, because they are all approximate. But you have to have the sense of the layers. This will deal with it when we study about the layers of the Earth itself. You will find that it is different from one textbook to the other, but you have, if I tell you the thickness of this layer is a value, plus or minus 30–40%, it is okay. But if I give you a number that is 3 times or 4 times, then it is not correct. So this is the engineering sense that you will need to understand. So in geology, distances and dimensions are in kilometers. They are all approximate, but we need to have a sense for the relative distances. This is we. The atmosphere. The atmosphere is the layers of gases that envelop Earth, and it is held in place by the Earth's gravity. This is very important. Do all planets have atmosphere? No. Some planets may not have atmosphere. To have atmosphere, first of all, what is atmosphere? Atmosphere is a layer of gases around us. It is very important for us, because if we don't have atmosphere, then we cannot breathe and we will die. So atmosphere is very important for the Earth. It's important for us, for animals, for any living creature needs the atmosphere. So the atmosphere is very important. How it is around Earth? Why does it go just travel in the sky? Two things. A planet retains the atmosphere when the gravity is great. It needs to have gravity to pull the atmosphere down. Otherwise, the atmosphere will go up. The other thing is the temperature. It must have a low temperature. If I tell you, does the sun have an atmosphere? No, the sun is very, very hot. How come it may have gravity? I really don't know. Is there a gravity for? I've never been there. But of course, scientists know if there is a gravity or not. But it is very, very hot. So anything around us will leave it and evaporate. So for us to have atmosphere, we need to have gravity, and we need to have a cool surface. Earth has gravity and a cool surface, so it has atmosphere. When scientists try to study other planets to study if there is a possibility of life on it or not, the first thing they will study, is it cool or not? Does it have gravity or not? High gravity or not? If it has, then it is supposed to have an atmosphere. Then if it has an atmosphere, then there is a possibility of life or not life, that people may go on top of it and live. The next is the study of the crust. We can have a break and continue after this break. So this will be our first part of the lecture. And the next part of the lecture, we are going to study the Earth. So far, we studied the reasons for the study and everything above Earth. Next, we are going to study the Earth itself.